11.9 is about binomial distribution. This is another type of probability since we're in the probability chapter. The key here are these 4 points. There has to be a fixed number of trials to be a binomial probability. Each trial has to have 2 possible outcomes. Win, no win. Whatever they're talking about, 2 possible outcomes. Trials are independent of each other, and then the probability of each outcome remains constant through the trials. Now I'll walk you through the calculus of how to do this, but as part of a promotion, a store is giving away scratch-off cards. Each card has a 40% chance of winning, so our probability, or P is 0.4, of winning prize. Suppose you have 5 cards. My N is 5, and you want the probability exactly 4 out of 5 cards will reveal a prize. And my X value is 4, because I want 4 out of the 5 cards will reveal a prize. So what you're going to hit when you get in your calculator, and we'll go through this again tomorrow in class, you want to hit binom PDF. Just write it down so you have it written down. PDF, and then it's going to be 5, and then your probability is 0.4, or your trials are 5, probability is 0.4, and your X value is 4, because I want 4 out of 5. And then that's going to give you 0.0768 is my probability that 4 out of 5 cards will reveal a prize. You want PDF, not CDF. We'll talk more about that tomorrow. Each hour of cell phone factory quality control tests the durability of 4 randomly selected phones. So my N is 4. If in 1 hour 95% of the phones made are acceptable, what is the probability that OC rejects that hour's phone production? Well, again, N is 4. If more than 1 fails, quality control rejects the entire production for that hour. So in 1 hour, 95% of the phones are acceptable. So what's the probability of failing? The probability of failing is 0.05. So what we want to do is find the probability that X is greater than 1. Okay? Because you want to know what's the probability that it rejects the hour's phone, because it says if in 1 hour 95% of the phones, where is it at? If more than 1 fails. If more than 1 fails, so what's the probability that you're going to get more than 1? So that's really the probability of 2, or the probability of 3, or the probability of 4 going ahead and failing. So there's a couple different ways we could do this. Again, like last one, it's binomial PDF. Our N is 4, our probability is 0.05, and our X value is 2, plus binom PDF of 4, 0.05, 3, plus binom PDF of 4, 0.05, 4. Add those up, you're going to get 0.014 is a probability of QC rejecting that hour's phone production.